You guys, this is one of my favorite sections, which means it's probably not going to be one of yours because I understand that I'm a little bit different and that's okay. But I want you to, what we're going to do is we're going to prove trigonometric identities. And if you do a quick like Google search of that, you see people freaking out about proving these. And they can be difficult because it takes time to really get good at math. It takes time, right, to see what you can do. And so you need to invest that time into doing them. So the way you get good at math is you do it. And the online homework is not going to be great for this. So you need to look at the fun sheet. You need to go in the book and maybe just work some of the identities out of the book. And you need to contact me if you have any questions or get some help from other people, because these take time to really understand, and you got to practice them. It's not just going to be some formula that you put in and it's going to be the same thing every time. It's going to be different. So proving trig identities, what we're going to give you is we're going to give you something, some statement that's true. Okay, so an identity is something that's true. Some of the identities we know so far, right? Here are the identities that we know so far that we are going to be using. So we know, sorry, I don't know what's going on with my pen. That's kind of... So let's write these all down really quick. We know that sine squared x plus cosine squared x is equal to 1, right? That also, from that, we know then that cosine squared is 1 minus sine squared. And we also know that sine squared is 1 minus cosine squared. Whoops, I need a squared in there. What else do we know? We know that if we divide everything by cosine squared, right, we get tangent squared plus 1 equals secant squared. From that, if we solve, we know 1 equals secant squared minus tangent squared, right? Or another way we could do that is tangent squared. Oops, let's get a little bit of, I want this to kind of stay the same. Tangent squared is secant squared minus 1. Okay, and then if we divide everything by sine squared, right, we get 1 plus cotangent squared, or cotangent squared plus 1 equals, remember, cotangent and cosecant are friends. I mean, they're all friends, you guys. Come on, they're all friends. Cotangent squared. And if we subtract 1, we get cotangent squared equals cosecant squared of x minus 1. Okay, so those are my Pythagorean identities, right? We know those. We've come to know and love them. What are some other identities that we know? We know our sum and difference formulas. So like if I use x and y, sine of x plus y is sine x cosine y plus cosine x sine y. Sine, cosine, cosine, sine. Same thing if I have minus, right? We have same thing here, except I'm gonna put a subtraction sign. And I just want to get these all written down because we're going to use them. Cosine of x plus y. Remember, that's cosine, cosine, sine, sine with an opposite sign, S-I-G-N. And this is good for you to also just put these in your notes. Maybe have a reference page where you can come back and kind of see all of these. When we go to prove some of these identities, sometimes if you don't know them off the top of your head, right, it might be good to have a little something like this. So those are our sum and difference formulas. We have our double angle. Well, we have the tangent ones also. I'm not going to put those down right now just for space sake, but the tangent ones, of course, you can look up also. Oh, sorry, not sine. So the double angle for sine is 2 sine cosine, right? And the double angle for cosine, which we can get just by plugging in x for y in your sum formula. This is cosine squared minus sine squared, right? So those are some of our big identities that we're going to want to know. And then, of course, what else do we know? These are pretty obvious, hopefully. But tangent, right, is sine over cosine. Cotangent is cosine over sine. Okay. Oh, our half angle formulas. Those are pretty obvious, hopefully. Our half angle formulas I'm going to actually write a little bit differently, but sine squared x, right? Well, do I want to do it that way? Actually, I'm not going to write those down. If we need those, we'll grab them. But I do want to write down really quick also our reciprocal functions. What do we know? Secant, right, is 1 over cosine, or cosine is 1 over secant, and cosecant of x. You have to be taking the cosecant of something. Sine of x without the x is just a sin. Man, that's funny. All right, so these are some of the things. So when we say these are identities, these are things that we've proven before. Like I believe, I don't know if I proved the sum formula for you, but I proved the Pythagorean identities for you. We proved the double angle formulas. These are the ones that we already know are true that we're going to be able to use when we do our when we prove these identities. So what do I mean by proving an identity? What I mean is we're going to be given something. Like one we're going to be giving is something like this. Secant squared of theta minus 1 all over secant squared of theta equals sine squared. Okay, we'll get to this eventually. This is an identity. This is true. Secant squared minus 1 all over secant squared is equal to sine squared. Now, it's not an identity that we're going to memorize, right? It's not like the double angle formula or the sum and difference formulas, because it's not an identity that really is going to be useful for us all the time. But what the exercise in proving these identities is going to do is it's going to get you familiar with using all of these identities from this first layer here, these identities, getting you used to working with them. We are, I'm teaching calculus right now, Calc 1, and we're simplifying a lot with these trig functions, and some of my students don't remember how to do this. So it's important that you know how to do this. It's important that you are feeling comfortable with working with trig expressions and manipulating them to get what we want. The other thing that this is useful for is in section 7.4, we're going to be talking about solving trig equations or equations involving trig functions, and we have to know how to simplify those to be able to get what we want. So let's start off with a couple tips, okay, or some guidelines, and then I'm just going to do a bunch of examples for you. So here are some tips. Okay. One quick thing in your book, your book says, so if I have, why did I erase that? If I have something like this and I want to prove to my teacher, right, or to any person, you know, that just comes up to you in the grocery store and is like, quick, prove this identity. I mean, how many times has that happened to you? If I want to prove this, what I want you to do, and because you're taking my class, you will do what I say. It's a little bit of power that I have. I don't have much power in my life because I have, you know, little kids and they pretty much control me. But the little power I do have in my life is I'm going to tell you how to do this. So your book says you can work with either side. Now, while this is true, meaning you can take this side and simplify it down to be something, let's say C, and then you can take this side separately and simplify it down and you get some C, and obviously C is C. The way this works is if you want to show that A is equal to B, I could show first that A is equal to C, then I could show that B is equal to C, and then by the transitive property of that equal sign right there, you don't have to really worry about that too much, we've shown that A equals B. Now, that mathematically is a valid way of proving an identity. However, I have been teaching math for quite a while. I know it's crazy because I sound so young, right? I started when I was like 10 years old. I have been teaching college math for quite a while, and I have found that when I let you use both sides, the problem I see is I see someone saying, okay, I'm going to just multiply, I'm just going to multiply both sides by secant squared. Okay, because Sarah said I could use both sides. So I'm going to multiply both sides by secant squared. So the minute you do that, you have actually already assumed what you're trying to prove. If you assume that this equals sign is true and you multiply both sides by secant squared, that means you're saying that this equality does hold. And that is mathematically incorrect, okay? So we cannot assume that that equality holds. So I cannot work with both sides of the equation at the same time. I can't like multiply both sides by secant squared or add something to both sides, because then if the minute I do it to both sides, I'm assuming that this equal sign is true. And when we're dealing with trig identities, what we're dealing with is we want to show that this is true. I want to show you that secant squared minus 1 over secant squared is sine squared. That's my goal, is to show you that that is true. So while mathematically, if you work with each side separately, that actually is not mathematically incorrect, I'm not going to let you do that because I've seen too many mistakes of students not understanding what we mean by working with each side separately. So to avoid that, to make sure that we're staying mathematically correct, okay, what I am going to force you to do, again, my little bit of power here, aren't you glad you're in my class? Is I'm going to force you to work with only one side. What you're going to do is you're going to pick one side to work with, let's say this side, and you are going to work with it, and you are going to show that just this side simplifies down to sine squared. You're going to do some equal signs in here. I'm going to be a little bit picky about notation, and you're going to simplify this so that you get sine squared. Notice how I did not assume anything about this side. I am only taking one side. I'm working with that one side, and I'm showing it equals the other side. It is going to keep us it's going to keep that confusion of working with the equal, on both sides of the equation. It's going to keep that confusion at bay. Okay, so do what I say. All right, so here are my tips. You are going to start, so you're going to start with one side and show that it's equal to the other side. My tip is always you want to start with the more complicated side. If I started with sine squared, I don't really know what to do with sine squared to get all this crap right here. Whereas if I start with all this crap right here, right, maybe I can write it in terms of cosine, or maybe I can factor. I don't know what I'm going to exactly do here. But what I do know is that if I start with the more complicated side, I can do more stuff with it, right? I can simplify it more. So you want to start with the more complicated side, and you're going to show that it equals the other side. So start with the more complicated, and that's a relative term, right? What is complicated? Well, if there's more stuff to do, if there's a fraction versus no fraction, if there's an addition sign versus no addition sign, stuff like that. So that's what we mean by complicated, okay? Then number 2 is, if possible, what you want to do is you want to carry out any algebraic manipulations, if possible. So, if you can combine any terms, you want to do that, right? If you can add, subtract, any arithmetic stuff, multiply, likewise, not really divide, but maybe you could factor, stuff like that. Sometimes factoring works out really well. We want to look at, are there any algebraic manipulations that I can actually perform? If you can't perform any of those algebraic manipulations, if a fraction is involved, if there are fractions, here are some suggestions for fractions. Combine like terms, or combine, excuse me, using a common denominator. So like if I'm adding 2 fractions or subtracting 2 fractions, guys, it's hard to do spelling. Denominator, probably. Whatever. Combined with a common denominator or clear a complex fraction. That's what I'm going to do with this one. I'll show you. Anything like that. If I have a fraction, fractions actually, sometimes you don't like to see fractions, but when I'm dealing with trig identities, I really like to see fractions because that means I have stuff that I can do. If I see this fraction here, I'm like, ooh, this might be good because I can probably do some stuff with it, right? Whereas if I don't have a fraction or something, I'm like, well, what am I going to do? I don't know what to do. Number 4, if possible, if you're really stuck and you don't see quite what to do, what I would really recommend is converting everything, and this isn't always going to be true, but a lot of times this is going to be helpful, convert everything to sine or cosine, to sine and cosine. Okay, so like that's going to be my first step up here when I have these secant squareds. I'm going to actually write everything in terms of cosine because there's not a whole lot I can do with this as is. But if I rewrite secant squared as 1 over cosine squared, then I have a complex fraction that maybe I can simplify, okay? This number 4 usually works pretty well, converting everything to sine and cosine, okay? And then number 5, I'm just going to put try something. Don't just look at it and say, I don't know what to do. I'm just going to not do anything. Guys, part of mathematics is making mistakes. So, maybe that's not the final answer that you show me, but part of mathematics and becoming good at mathematics is being willing to try something and being willing to fail that first time. That's okay. Maybe we'll try something and it won't work right away. Maybe we started with the wrong side of the identity and we need to go back and work with the other side. But it's not always going to work perfectly every single time, and that's all right, because you're gonna have to allow yourself to make mistakes, and you're just gonna have to try something. Try combining a fraction. Hopefully, you know, that something you try is mathematically valid. That would be a plus. But you just need to try something. Okay. So I'm just gonna now that I've written down those tips for you, I'm just gonna do a bunch of examples. So let's look at that first example. So all of these, I'm going to write down an identity, and my goal is going to be to prove it. So let's look at secant squared minus 1. This is what I want to prove. I want to show that secant squared minus 1, all divided by secant squared, is equal to sine squared. Okay, I'm very picky with notation when it comes to these. What you need to show me is you need to clearly state what side of the equation you're going to work with. So you remember, you pick one side, you don't work with them both at the same time, because there's confusion there, so I don't want you even to do it. I'm going to start with one side of the identity. Which one is the most complicated? Clearly the left-hand side is the most complicated. So you guys, don't be lazy. Rewrite the left-hand side. I know it's going to take 2 seconds of your life to do that. I'm sorry to take that 2 seconds away. So remember, I'm writing this for someone to read, mainly your teacher, who gives you your grade, right? So I'm going to write down the left-hand side, and it could have been the right-hand side. I don't know, you know, whatever one's most complicated. And then I'm going to put an equal sign. So what I'm going to do with this is, when I first look at this secant squared minus 1 all over secant squared, there are a couple things that we could, you know, think about doing. So if I look back at my identities here, now remember, there are a lot of different ways we can do this. Secant squared minus 1 is tangent squared. That actually might be the way to go. Now, when I first looked at this identity, I didn't quite see that, and I didn't think about doing it that way. But then I kind of looked at that secant squared minus 1, and I'm like, I think I have an identity for that. So notice that's why this would be good to have this sheet out with all of these identities. Notice that secant squared minus 1 is equal to tangent squared. So that's going to be the first thing that I do. I'm also going to show you the way that I was thinking of doing it before I saw that secant squared minus 1 was tangent squared. Okay, so secant squared minus 1, I'm starting with the left-hand side. I want to show that it is the right-hand side. So, secant squared minus 1 is also known as, is equal to tangent squared. We've proven that, so you don't have to prove that. Okay, all those on that first page you don't have to prove. And then this is all over secant squared. So I have tangent squared over secant squared. Notice, what do I want to get to? So I want to think about what I want to get this guy to look like. I want it to get to sine squared, right? Well, right now, tangent and secant are not in terms of sine and cosine. So I'm going to actually rewrite in terms of sine and cosine. So what is tangent squared? Tangent squared is sine squared over cosine squared, right? That is the definition of tangent squared. What is secant squared? 1 over cosine squared. Okay, so look what I have now. I have a fraction. Now I can put an equals. Oh, I might run out of room here. How do I divide fractions? You flip and multiply, right? So that I take the top. So this is some stuff hopefully that you remember. The numerator, and then I multiply by the reciprocal of the denominator. So what's the reciprocal of 1 over cosine? It's cosine squared. It's cosine squared over 1. Oh, these are so fun. And then these cosine squareds cancel out, and I get sine squared. Yay! And then I do a little happy dance in my office because I've shown it's true. Or in mathematics, sometimes we put this little colored in squared to say, we don't actually put smiley faces. I put smiley faces, but we put that little squared to say that we are done. We've shown that that is true. So that was a pretty nice way of showing, you know, that this complicated side over here equals sine squared. The other way you could have done it, and this was the way that I actually was thinking of doing it, which was the wrong, well, nope, I'm not going to say the wrong way. I'm going to say was a bit of the more complicated way. But if I didn't see right away that secant squared minus 1 is tangent squared, I'm going to get everything into terms of sine and cosine. So I'm going to rewrite secant squared as 1 over cosine squared all over 1 over cosine squared. Okay, and then I'm going to do a trick of clearing fractions that I hope you will embrace. What are the denominators that I have? So notice I have a complex fraction, meaning I have a fraction inside a fraction, okay? And the denominators that I have are cosine squared, and they're exactly the same. So I'm going to multiply the whole numerator by cosine squared, and what I do to the numerator, thou shalt do to the denominator. It's one of the important math commandments. And so I'm going to multiply top and bottom by cosine squared. Why did I do that? To get rid of the fractions. Look at what happens here. what is 1 over cosine squared times cosine squared? Well, that's just 1, right? Here, I get 1 times cosine squared, so I just get minus cosine squared, right? That's why, and then on the bottom here, when I multiply these two, these cancel out, and I just get 1. Guys, that's why we did it. That's why we did it, was to cancel it out. Again, what did I do? It's a complex fraction. I have a fraction inside a fraction. I look at my denominators that I have, and I multiply by the common denominator on the top and bottom. Because they were the same denominator, I just multiply by cosine squared. And then, guys, what is 1 minus cosine squared? That is one that I know right off the bat. 1 minus cosine squared is sine squared. So we are done. I don't know which one you like better. I actually kind of like this way where I rewrite it in terms of cosine. That's kind of my go-to. But let's do another one because we should, and they're fun. And I have had students, I mean, they won't say it out loud if their friends are around, but I've had students tell me that they really enjoy doing these. And I think once you start doing them, you'll really enjoy them also. They're just a good time. So what about something like this? I'm just going to keep using, well, that was theta. I'm going to go to x's because let's show that 1 over 1 minus sine x plus 1 over 1 plus sine of x equals 2, I keep using secants, but that's okay, 2 secants and sines, 2 secant squared of x. Okay, so clearly the more complicated side is the left-hand side. Rewrite it, don't be lazy, rewrite it. Okay, again, remember, I can't work with both sides of the equation. You're like, well, Sarah, why do you keep telling me this? Because I've seen it, guys. I tell you, and then you do it. One of you out there is going to do it, and it's going to make me so sad. All right, so what I'm going to do here is I'm going to get I have 2 fractions added together. So one of those tips was if we can, right, carry out algebraic manipulations. More specifically, if we have a fraction, maybe combine the fractions. So I can combine them, right? I'm going to get a common denominator. So what am I going to need? This guy's going to need a 1 plus sine x. This guy's going to need a 1 minus sine x. So I want to show you every step. So let me give myself a little bit of room. 1 minus sine x, okay, plus 1 over 1 plus sine x. So I am going to multiply this one right here by 1 plus sine x, right, all over 1 plus sine x. That's my common denominator, and then this one gets 1 minus sine x, or that's to get my common denominator. Okay. All right, so what do we get here? So on top for this guy, I just get 1 plus sine of x. On top for this guy, I get plus 1 times 1 minus sine x, so that's just 1 minus sine x. And then on the bottom, what do I have? I have 1 plus sine x, which we're going to FOIL this out here in a second, times 1 minus sine x. Oh, this one's so much fun, you guys. Okay, so again, I just got a common denominator. I multiplied the top and bottom by the denominator of this one, multiplied this one, top and bottom by the denominator of that one. I just got a common denominator. That's all. That's not scary. It's not scary. All right, so the sine x's cancel on the top. I'm just left with 2 on the top, and then let's FOIL out the denominator. Notice the denominator is a difference of squares. So if I FOIL this out, I get 1 minus sine squared x. Nope. The sine squared doesn't come. I get 1 minus sine x plus sine x minus sine squared of x. So my sines cancel. So remember, a difference of squares, those middle terms cancel. So I get 2 over 1 minus sine squared x. What is 1 minus sine squared x? Well, we saw that before. That is cosine squared. And then what is 1 over cosine squared? Well, 1 over cosine squared is secant. So basically, I can just rewrite. I mean, technically, what I've done is I've thought of it like this. Right? That's technically what I've done. You wouldn't have to show that though. And I get 2. That is exactly what I wanted, right? I wanted 2 secant squared. And so that's what we got. And always look back and like see, okay, where do I want to get? Like once I've simplified it down to here, like is that where I'm supposed to stop? No, what do I need to get this to look like? I need to get it to look like 2 secant squared. So I have one more step to do, right? I have one more step to show me. When in doubt, show me each step. I shouldn't have to guess how you got from one step to the next. Like if you went from here and you went straight to here, that's not sufficient. Like I need to see some of those steps in between. Okay, so show me your work, show me the steps so that if you make a mistake somewhere, I have partial credit to give you. It's pretty, yeah, anyway, I'm gonna stop with that. Let's look at another one. I'm just gonna do a couple more examples for you. The problem, so I realize that there's not one method for all of these. You're just gonna, I know I've already said this, but you're just gonna have to, you're gonna just have to work with them. You're gonna have to practice. There are lots of examples in the book. If you want more examples from me, I'm happy. I have a lot of math books. I can even scan some pages for you. And just give you more and more. I mean, the good thing is you know what you're supposed to end with, right? So so it's good to you know what you have to end with. So I don't know what I was saying there. You know if you're not going to be right. All right, what side is more complicated? This one's a little bit tough. I don't know, the right-hand side, the secant times cosecant, I don't think I'm going to be able to do a lot with that. So I'm going to start with the left-hand side because at least there's some addition there. Now you're probably wondering, like, but Sarah, I can't add cotangent and tangent, which is true. I can't add those together. So when in doubt, let's turn everything in terms of sine and cosine. So I'm going to rewrite tangent. I'm going to write that as sine x over cosine x plus cosine x over sine x. So really, this has a fraction that is hiding there that maybe we didn't see at first, but I really just have a fraction now that I can combine. So what are my common denominators going to be? Well, this one needs cosine, so this one needs a cosine, right? And then this one needs a sine, so I'm going to put sine x over sine x for this one. And now I'm ready to get my common denominator. So this guy in the numerator is going to give me a sine squared. This guy in the numerator is going to give me a cosine squared. And then I'm going to write this as cosine x times sine x, or sine x times cosine x. It doesn't matter because multiplication in the real numbers is commutative. Even in the non-reals, it's commutative. What now? Okay, so I have this beautiful fraction. Now, I mean, you should be just ecstatic that you see a sine squared plus cosine squared, because what is sine squared plus cosine squared? You are right, it's 1. So this is 1 over cosine x times sine x. Now let's look back at what we want to get this identity to be. We want to get this identity, right, to become secant x times cosecant x. Well, what do I know? Secant is 1 over cosine, and I know cosecant is 1 over sine. So I'm going to, I could just go straight here to secant times cosecant. That is fine. But I really want to, drive home the point that this guy, I can break up fractions across multiplication like this, because remember, how do we multiply fractions? We just multiply straight across. So I could rewrite this fraction right here as 1 over cosine times 1 over sine. What is 1 over cosine? That is secant. And what is 1 over sine? That's cosecant. And I'm done. I like the smiley face. I think we should do the smiley face more. Okay, cool. Let's see, what else? Let's try, I want to do another one maybe that involves some factoring. So let's clear this out really quick and let's try another one. So how about, let's do, I'm trying to find one here in my notes. Yeah, let's do this one. Sine squared of alpha minus sine to the 4th of alpha equals cosine squared of alpha minus cosine to the 4th of alpha. So I don't know exactly what I'm going to do with this one, but I do know, I know a couple things, right? So it doesn't really matter which side you work with, because in this case, both sides are, this is kind of a cool identity actually. Both sides are really the same complexity. So I'm just, because I'm used to working with the left-hand side first, I'm just going to work with the left-hand side first. And what I could do right now is I could get everything in terms of cosine. But before I do that, I notice, right, that these two terms right here share a common factor. And what is that common factor? That common factor is sine squared. So I'm going to go ahead and take out a sine squared. And I kind of like taking out a sine squared because I know that I can rewrite sine squared with a cosine squared. So if I take that sine squared out, what am I left with? I'm left with a 1, right? Minus sine to the 4th divided by sine squared, I'd be left with 2 sine squareds. And then what's nice about that is I know, right, and these you should be able to start recognizing, what is 1 minus sine squared? 1 minus sine squared is cosine squared. So this is great. I mean, we're getting pretty close already. This whole thing is cosine squared. Now, again, what do I want to get to? Let's look back up at what I'm trying to get to. Notice everything here involves a cosine. So what do I have that does not involve a cosine? This guy right here. So let's rewrite sine squared. Sine squared is 1 minus cosine squared. That's why I like the squareds. And this is all times cosine squared of alpha. And now the last thing I just need to do is multiply that cosine squared through. So we get cosine squared alpha minus cosine squared times cosine squared is cosine to the 4th of alpha. And we're done. Look at that. Isn't that great? That one was fun. I enjoyed that one. Did you enjoy that one? Yeah, I did too. Good. Good. All right. We're at 30 minutes. I want to do maybe 2 more. And then we'll call it good. And then what I'd like to do is I'd like to write down something called the sum to product formulas. We're not really going to use these, the sum to product identities. I'm going to write them down so you've seen them before. I honestly, in my math career, don't really use them very much, but maybe, you know, I know most of you are health science, but once you, who knows, maybe in medical school, you'll have to know the sum to product identities, and you'll be cursing me if I didn't give those to you. So let's look at one more. What if we had cosine of x? Hold on. I actually want to go the other way here. Oh, I have an email. We'll worry about that later. Okay, what if I had cosecant of x equals cosine of x, cotangent of x, all over 1 minus sine x, all minus 1. Okay. So I have this identity. Clearly, the right-hand side is the more complicated side. Now, I don't have this one in my notes, you guys. I just grabbed this from a different book. So I really want you to see, I'm not sure what's going to happen. And I want you to see that because I want you to see that the process of it. So when I look at this right away, I'm like, ooh, I don't quite know what to do. So, but what I do know is I can mess with this fraction. Now, I am going to combine these two eventually. I'm going to take this one and I'm going to combine it with this fraction. But before I get there, what I want to do is I'm going to turn everything in this fraction right here in terms of cosine and sine. So what is cotangent? Cotangent is cosine x all over sine x, right? And then I have this all over 1 minus sine x. And then this is all minus 1. Okay, and let me put that minus 1 a little bit over because I see I'm going to do something here. So, okay, so I have this fraction. I am going to combine this with the 1 eventually. But when I look at this, I don't like the complex fraction. Remember, this is cosine x over 1. And how do I get rid of a complex fraction? I take the denominators that are inside the complex fraction, which in this case is just sine and 1, so I don't worry about the 1. And that's the only denominator I have. So I'm going to multiply the whole numerator by sine of x, but if I do it to the numerator, you best be doing it to the denominator. So look at what I get here. There's a reason I did that. That's because these signs right here cancel. That's why I did it. And so what do I get on top? Sorry about that. I get cosine squared x on top all over. I'm just going to, we can multiply that through. Sine of x. No, I don't want to multiply it through actually. I'm going to just leave it in a factored form. 1 minus sine x. Okay. And this is all minus 1. And now I'm going to get a common denominator. So what do I get on top? I have cosine x. We're getting there. Don't worry. Cosine squared x. And there might be an easier way to do this, but this is how I see how to do it. I'm going to multiply this 1 by the denominator, which is this. I'm just going to put that here and over here, right? This guy right here. So look at what I'm going to get. I'm going to get cosine x minus this guy, sine x, times 1 minus sine x. And now I am going to take that sine x through here in a minute. And this is all over. I'm going to leave the denominator in factored form for right now. I don't know why I'm doing that, but okay, I kind of do know. I want to get to cosecant, you guys. That's what I want to get to. And I know cosecant is 1 over sine. So I am guessing that this is where my 1 over sine is going to come from. And my thought is that this guy, this 1 minus sine of x, is going to cancel out. That's why I'm leaving it in factored form right now. So just to give you kind of my thought process on that. So in the numerator, let's see what happens. I get cosine squared x. I'm going to take that sine x through. You can't cancel those signs. Don't you dare. Don't you dare. I'm going to get minus sine x, and then I get plus sine squared x all over sine x times 1 minus sine x. Oh, guys, this is so great. This is so great. You're going to love this. Okay, hold on. Let me clear this layer. And so look at what I have. Let's write back down what we have. We have cosine squared minus 1 plus sine squared. Nope, not minus 1. That would be bad. I would get 0 in the numerator. We don't want that. Minus sine x, excuse me, plus cosine. No, Sarah, sine squared. All over sine x. Again, I'm leaving that denominator in factored form because I'm really, remember what I want to get to. Let's keep our eye on the prize. We want to get to cosecant x. I really want this 1 minus sine x to cancel so that I have 1 over sine x, which is cosecant. And you guys, it's good. It's so great. What is cosine squared plus sine squared, people? That's 1. So on the numerator, the cosine squared plus sine squared, those together become 1. And then I get minus sine squared, or no, minus just sine on top. Sorry, I'm getting a little too excited about this. I love doing these. They're so fun. And then sine x times 1 minus sine x. And now notice the 1 minus sine x cancels. And I get 1 over the sine of x. And that equals cosecant of x. Ta-da! Isn't that great? That one was super fun. I really enjoyed that one. That was a good time. Now, I get it. These are easy for me. I've been doing math for a really long time. It's my passion. So I know that that maybe necessarily isn't yours. You have to practice these. You have to do the fun sheet. You have to sit down and do stuff. You have to try and make mistakes. If you get caught up, send me a picture of your work, email it to me. I will email you back. I'll give you some suggestions, some hints on where to go from there. But take some time out of your schedule. Make sure you block some time out to do this, not just during class. You need to do this at home. You need to do this, practice these. Get the book out. In 7.3, they have quite a few that are, they have a lot of identities there that are really good to do. And the last thing I want to do is I just want to state for you those sum to product formulas. So the sum to product identities, just write these down. I don't expect us to really use them, but they might be useful. I don't know. Who knows? I always say things like that. Oh, we're not going to use them, and then we end up using them. But I'm not going to prove these for you. You can use these. We can prove using the product to sum, I think. Or these are the sum to product. Oh, they're all of them. Sum to product and product to sum. Let's just say, I'm going to write these all down at once. Sum. Sorry, I skipped a page there in my notes, / product. So the first ones, and you can verify these, you can actually verify them pretty easily, but we know sine x times sine of y, so this is product to sum, excuse me, equals 1/2 of cosine of x minus y minus cosine of x plus y. And these are actually pretty easy to verify. If you just use what's more complicated side, right? If you use this right-hand side and you use the difference formula and the sum formula for cosine, you can see that these come pretty easily. Oh, sorry, I wanted cosine there. Actually, that would probably be a good exercise, is for you to prove these identities. And this is 1/2 of kind of the same thing, only it's plus. That's not plus, the middle is plus. Okay, and then if I have sine of x, so sine and sine, cosine and cosine, or I can get sine cosine. Okay, this is 1/2. We just use the sine ones. Sine of x plus y. Okay, plus sine of x minus y. Again, I don't need you to memorize these, but they're just good to know. or to write down at least. You should prove these. These would not be hard to prove. Start with the right-hand side and go back, you know, to that first layer. Oh, that looks cool. And use these formulas here. Start with the right-hand side, use those formulas. And you can quite easily, maybe not easily, but you can. It is possible to prove these, okay? And then likewise, if we go the other way, so the other, I'm going to let you look at these in the book. So in the book, this is on page 610 in the book. But the sum to product, you could just solve. It's actually not too bad. You could solve for the sine of x plus y, and they do. Then you can solve for that. Then you can find sine of x plus sine of y, sine of x minus sine of y. So page 60, write down those other 4 identities. Okay, 610. What did I say? I don't know. 610, that's what I meant. Anyway, clearly I'm not really too worried about these for you, but I want you to write them down in your notes so you have them. So look in your book, look up the sum to product identities. These are the product to sum, and you can use these to prove the ones in page 610. Oh, we're at 40 minutes already. Guys, you gotta do these. You gotta do these identities. You have to practice them. If you come across one where you're just not even sure what to do, I need you to let me know or let someone else know and get some help. All right, enjoy.